automatic project loads a series of photos and automatically marks, references, and orients them. There are two types of automatic projects: smart projects, covered in a separate tutorial, and targeted automatic projects, which this tutorial will cover. For a targeted project, the first thing you need to do is create the targets. You can do this by going to File, Create Coded Targets. This dialog allows you to create various types of targets. Usually, the ringed automatically detected, or RAD targets, are the best choice. There are 999 unique codes for RAD targets. We will arbitrarily use targets 703 to 960. To be detected, the center dot of any target needs to be about 8 to 10 pixels across. The Estimate button can help you come up with a physical size that will be about 10 pixels across, based on the focal length and resolution of your camera, plus the distance to the furthest target. For this project, we will use targets with a 10mm center dot. We will also show an optional special feature, paired targets with offsets. This will print out pairs of targets with an extra indicator showing where an offset point can be created. This allows us to place the targets and offset in corners or other places a regular target could not be placed. When you cut out targets, you want to ensure there's sufficient white space around the edge of the outer ring to provide a contrasting edge, allowing the ring to be detected. Once the targets are printed, they can be added to the scene, the photos taken, and then to start an automatic project, select Automated Project from the Getting Started dialog. Usually, RAD targets are the best choice, but for legacy coded targets or a mix of coded and non-coded points, you can use the additional parameters path. We load the photos and a calibrated camera is matched from our library. See the camera calibration tutorial videos for more information on camera calibration. After hitting run, our targets are detected and the project is processed. Resulting in 118 3D points. Here are the solved target locations and the solved camera positions. For many projects, where the target locations are the items of interest, this is all that will be needed. For example, here we can tell where the plane of each stair is. However, in this case, we also use paired targets to indicate where offset points should lie. We go to Project, Coded Target Offsets, and choose the RAD offset type. Pressing Apply Offsets prompts us for the range of offset points. Since all of our targets are paired offsets, we can use the full range. If you had a mix of single targets and paired offsets, you would need to specify the range of paired targets. If you use offsets frequently, there is a setting on the Preferences dialog to apply these offsets automatically during the wizard, removing the need to manually apply them. Now that the offsets are created, we can view them in 3D. After adding lines between the offset points, this is what the stairs look like. We intentionally left a set of targets off these parts of the stairs to show that you can add manually referenced points to a targeted auto project. In some cases, the targets can be used purely to solve the camera positions and strengthen the project. Just place targets in arbitrary places in the scene, then manually reference the points of interest. We use the Mark and Reference tool to add the 2 points, and here's the full stairs project. If you want to add a scale, rotation, or translate using known coded target information, you can do this on the Preferences dialog, have it applied during the wizard, or import a coded target file using the External Geometry Explorer. See the related video. You can also select coded points to manually set up your coordinate system. See the related videos on scale, rotate, and translate, and other ways to define a coordinate system. Here we have another project that was set up and solved using the automated project wizard and legacy coded targets. The car roof box has also been applied with simple circular dots. These could be detected during the wizard, but we will use them to show other ways to detect targets. To mark individual targets or small sets of targets, you can use the subpixel marking tool. To mark regions of a photo, whole photos, or set of photos, you can use the automatic marking tool. The coded targets have already been marked, so we select the dot type. We will set the search range size for the dots. And mark all of the images. Since dots do not have the unique pattern that coded targets do, the marking stage has no way of matching the dots across images. Here we can see two photos have all their dots marked, but we can see in 3D that they do not have their positions solved. This is because they have not been referenced between photos. When you have a well-oriented project with unreferenced marks, you can use the automatic reference tool to match the marks across photos. Marks must be found on a minimum of 3 photos, but if you have more, it will add to the redundancy and improve the automated referencing. After running automated referencing, here's the resulting project. If a large number of points were added by automatic referencing, it can be a good idea to run processing so these points are refined and used to adjust the camera positions. To help visualize the result, we can select all the points and fit a surface to them. PhotoModeler has no way of knowing which way the surface should face, so we select it and flip the surface. We increase the U and V values to improve the fit of the surface. This concludes the automatic targeted project tutorial. We've learned how to create coded targets, use coded targets in the Auto Project Wizard, create coded target offsets, run auto marking and auto referencing directly, and fit a surface to a set of points.